I was wondering if that was just my device or not.
Ladies and gentlemen, so if you can all swish this way for any newcomers, and we will now have Senior talk about observability and the dev process.
Hello. I'm Christine. I'm a co-founder of a startup called Honeycomb. But the content of this talk came from my time spent as an engineer building developer tools at Parse, Facebook, and Honeycomb. There's a disclaimer here. The content is vendor agnostic, tool agnostic. You don't care what tools you use, so long as you try to integrate some of these practices into your development process. So I want to share today some of my lessons learned in building tools in a space that most people think about as just being in the ops world. But really, I'm like, well, the ops folks on record saying this, and we all know developers say things like this, but there's so much good that can come from two of them being like peeking into each other's worlds and seeing how they can work together. And this contract with the users of your service is what unifies us, right? That's why we're here. Theoretically, you're on the same team. So we're in this together and should be working to provide a good service to our users together. For years, people have been talking about the DevOps movement, teaching ops people to code and making them automate their work. That's cool. It's great. We're catching on. It's a good idea. What about the other direction? What about ops dev? Or teaching developers to own their code in production, to feel comfortable digging around, asking questions, treating production almost like with development machines. And I'm here to propose that observability is that bridge. This thing that helps developers go from understanding how their code runs on their machines to understanding how it runs in production. Observability is all about answering questions about your system, as JDD said, holistically, and that ability is as valuable for developers, the folks writing the code, the people running, testing the code, as it is for the operators deploying and maintaining the machines. So again, lots of people here monitoring observability, they think monitoring and ops. And that's certainly a big part of that is true, or else I probably have had to fight a lot harder to be in this room. And certainly a lot of the tools and resources in this space are focused on ops concerns. But what if those tools, and what if these techniques spoke a language that developers are already using and thinking about in their daily lives? Things like build IDs, things like customer IDs, endpoints. What part of, okay, you're telling me that latency is up, or you're telling me that throughput is down. In what part of the service? In what part of my API? What part of my code is being affected or is probably related to this problem we're seeing? Another reprobable characteristics, right? When dev throws code over to ops, here's this black box, and when ops looks at this black box, it just says, the CPU is up. What do developers use to figure out why and how to fix it? They're like, okay, well, help me isolate the problem, help me reproduce the problem so that I can fix and figure out what's going on. The more we can bridge this gap between what ops sees, CPU example, slides are also online, so I don't contrast, it's not great. By talking about what production sees, it's not about ops versus dev, it's about what is happening in production. The more that ops folks and devs can share responsibility for what's happening. These days, software development is usually super customer focused, right? There's all these great practices about writing design docs, architecture reviews, TDD, more tests, code reviews, CI and CD, and then we ship and we celebrate and we're like, awesome, my code is done. And then we just sit around and waiting for customers or exception trackers to tell us that something is wrong. What happened to that diligence? What happened to all that curiosity up front when you're like, oh, I've got to make sure these cases are covered, these things, I'm going to explore all these things and capture them in test cases. Well, we know why. It's a lot easier to isolate, reproduce, check for these cases on our machines than it is production, than in production. But during this development process, we've got all these questions about our system that don't smell like production monitoring, but can only be answered in production. And they're not all problems or anomalies. They're not all things that are going to pop up on their own. Instead, they're about hypotheticals. They're about specific customer segments, right? What happens if I make this change to the code? If I optimize this over here, will it actually produce the effect that I think it will? Often, this question is even just, what does normal mean, right? Oh, okay, this is what's happening. I want to make this a little bit better. Am I actually sure? Are we sure that this is what people are seeing? Or is this just what my test cases say it should be? By being curious and empowered to leverage production data to explore what our services are doing, we can have that data not only inform what we're building or what we're fixing, but how to build those, how to scope those, how to, again, make sure it's working, and how to roll it out. So here are some, very traditional standard production systems OPSI questions. It didn't take very much to turn them into things that, again, are production questions, or things that developers care about and think about, things that affect the business, things that are relevant to our users. Again, answers to these only live in production. You're not going to be able to simulate these on your laptop without going and looking what is happening, who's doing what, at what rates. Our tests are only as good as people who write them. We're great, we just can't think of everything ahead of time. Benchmarks can be a pain to run, and again, they're isolated. That's one particular thing you happen to think of. Exceptions aren't enough. Sometimes, as much as we try, exceptional behavior doesn't always result in exceptions. So what can we do to extend these great practices that we have in development into production? Because we can't wait for ops folks to tell us that something went wrong. That's depending on this external part of the development cycle. And the customer says, that you've missed an opportunity to be amazing. You're relying on them to do your QA, and that sucks for them and you. So we should be taking the initiative to get the same amount of visibility into production as we do in our development services. Let me tell you some stories and see how you feel. This is Bee. She's a software engineer on a small team and has to wear many hats. She's been tasked to improve how her team implements rate limits. So until now, rate limits were just in process, cache, small startup, resource constraint, where each service sort of tried to approximate the rate limit individually based on some global understanding of how many servers there are. While this worked well enough, this meant that as the team service grew, there was this kind of uncomfortable correlation between, well, more of the customer's requests happened to go here because the load balancer was having an off day. They're going to be rate limited more or less in some cases that it should. So it was, came a point where it was time to split up, share cache, clean up this tech debt. But instead of just making the change, he was like, okay, I want to be careful about changing what the customer sees. I can't just come up with my hypothesis about what will happen, push the code, and kind of hope for the best. So she wanted to know what data to gather to build confidence that this rate limiting algorithm would work correctly and not screw over too many current customers. By bringing data into the decision-making process, she could simulate the change and see what state behavior would be before flipping the switch and making her hypothesis real. So what she did, alongside the logic in her API server that calculated a particular rate limit for a request, she also added a bit that tracked whether it would be rate limited under the new algorithm. And this let her basically visualize, hey, this is what's currently happening. This is what would be happening in this brand new world. Code isn't actually shipped yet, but we're simulating this. And she could see, cool, rate limiting algorithm actually more strict in a couple more places. That's what it should be. That's what we expect. And she and her team were able to actually examine each case individually to assess, hey, this customer, this use case, is this what we expect to happen? Yeah, right? This is again, he's like taking these test cases out of development, looking at them in production, but where the test cases are actual users, actual workloads, actual machines. What's so special of iMachine anyway, right? That makes it so much more informative. This ability, well, obviously the ability to attach a debugger, spin up log lines, do a bunch of stuff without screwing over actual customers. But that's what we just did, right? That's how she got all the graphs in the previous slide. She captured this metadata. These are our debug statements. They're lightweight. They help us validate these hypotheses. They carry metadata specific to the business, and they describe the execution of our logic in the wild. They sound a lot like things that we want out of a debug process. All right, so this is B leveled up. She's got her debug statements in her back pocket. She knows how to do that. She's ready to do a little more. Now she's looking at the storage layer, and she's been working on some functionality to basically change, expand basically how she decides to lay out bits on disk. Details aren't important, sorry. What she knows is that it's something that will impact a small set of customers a lot, but shouldn't have a hugely visible impact on everyone else. But it's a very performance-sensitive part of the system. She doesn't want to just make a change without being sure about it. And she wants to see what will happen, again, with the production node on production machines. All the existing tests in the code base pass, and new tests, again, that she wrote to verify correctness, works well. But earlier we talked about translating these debug statements to production. Is there an equivalent to tests and testing in production? Of course there is. Not that subtle to speak of yet. You all know where this is going. The advantage of local tests, right? It's a controlled, safe environment where you can construct and execute tests. But we can do the same in production by using things like feature flags. You can find a test segment, add that to your observability solution of choice, and watch closely to see what happens. So she did. She rolled out her code behind her feature flag, turned on the new code, a couple customers, a couple machines. She was able to compare the same top-level performance metrics that she normally cares about, but able to directly compare the very small segment of folks in the feature flag group, the control group. And as confidence in the new storage layer increased, she was able to roll it out to 10% and 20% and the rest of the cluster, all while keeping a close eye on the performance metrics to see, hey, is everything kind of what we expect to see? These two graphs, she could actually see a very slight increase in latency as a result of the change. But it's expected, and it's within an acceptable threshold. And because, more than anything else, she could see and attribute that change to, okay, well, it's this set of, this code executing for this set of customers versus everything else. She could feel confident that, oh, okay, yeah, this is expected, this is correct, this is doing what I want. What she did here is similar to what a lot of us want to do with canarying. Right? Canarying you associate with rolling a build out, and single hosts, sub hosts. But again, that's thinking about things from an ops perspective. And if we roll back and we want to think about things from a business perspective or a unique workload perspective, some customers are string heavy, some customers are int heavy, then the choice of single server is arbitrary and possibly kind of dangerous. Instead, feature flags are like a smarter manual canary that developers can control. And remembering and being able to incorporate them into our observability tooling gives us the ability to define these ephemeral segments in our code to answer these ephemeral questions in a way that developers can work into their natural processes. Sometimes, though, even with the best intentions, we manage to release code with bugs or unintended consequences. The question that always comes up, knee-jerk reaction with a customer report, when did this start happening? Not necessarily because they're super concerned about the length of time it was live, although that was important too. Mostly because that's just the simplest way to map back to, hey, what commits, what pull requests, what new code was landed around this time. As any ops person will tell you again, biggest source of chaos in the system, usually humans. Usually humans pushing code off of new code, usually new code. So B got tired of this backwards timeline dance and got religious about tagging her data with build IDs, identifiers, something that helped her keep track of this code, when to do this build, when to cause these things on the graph. And once she got that going, this highest single piece of metadata available to the systems, she could immediately go from this to this. Something that goes from, hey, air volume kind of went up around this time, not really sure, maybe we should go find out what happened, to, oh, okay, well, this build ID is something. Let's go track that down. By making her observability tools talk about her system in terms that she dealt with day to day, she could go from this question mark, celebrate, and then be done part of the process, to start filling in that middle section, to start thinking about testing and production, to thinking about investigating outliers herself, in developer terms, not ops terms, and to really start taking initiative and exploring production, and hopefully to find problems, identify things before, again, either customers or ops are being undercovered. That's how we bridge this ops and developer gap. That's how we start engineers like me start thinking about what happens after they ship. Instrumentation monitoring, not just things developers can throw in at the end of the dev cycle. After they've been like, okay, everything works, we're all ready to go. They should be sprinkled in and continually checked, even as you're figuring out, hey, I think this is right, but I want to test it, I want to see the impact. And by capturing more lightweight, transient information in prod, before we flip the switch and actually ship the code to everyone, we can make better informed decisions and deliver better experiences for our users. Now we can have this be part of her development process. Rather than just writing code, writing a plan, shipping it in isolation, actually forming hypotheses about what's happening in production, and looking to see, hey, is the code I'm writing doing what I think it does? Plenty of us have had those experiences where we're like, hey, I have this great idea for performance optimization. I just want to say it looks great. Let me actually run it. Doesn't do anything in production. What if we could just cut out that chunk of time where we spend a bunch of time writing code for nothing? What if we could validate our processes and make sure we're doing the right thing, we're spending our time where it matters? All right, Christine, great. This all sounds nice and wonderful. How do we get here? What can we actually walk away with besides this high-level idealistic stuff? Well, I think there's instrumentation talk a little bit later. I suspect it will cover a lot of the same ground. But as we saw in how many of you were around the Prometheus Java talk earlier today, but there's a lot that can be gained by just capturing something around every HTTP request, right? For every HTTP server, capturing a little bit of something about which endpoint, which method, how long the request took, and start to capture a really high-level view of what's happening. And this is even just great for things like, hey, will anyone care if we make this change to our API every year? Is anyone actually using it? Or is it just all garbage? On top of those standard HTTP requests that we start off with, start sprinkling in some business relevant identifiers, right? These things that actually are descriptive of what the customer, what your workflow, what the workload looks like at that point, as well as any infrastructure-specific characteristics, Kafka partitions you're reading from or writing to, database replica sets, all that, throw that in there because at some point you're going to be looking at something strange, you're going to want to break it down, and you're going to want to find out that it's that one replica set again that's having problems. And those first two really set you up for the sort of ad hoc ephemeral queries that you saw in those two stories. As you find yourself asking these questions, hey, I'd like to make this change, what does success look like there? You can then find yourself ready, set up to capture the information necessary to actually answer those questions before landing that thing. And you end up with before, during, after this change, and really understand how what you're doing affects these echelon measures of health. And both of those examples we saw earlier, the rate limiting example and the storage system example, relied on data that we had to add, that was often added in parallel with the code being written. But it was so simple. Like if you make it simple enough, you make it easy enough for your developers to add these things on the fly, the more they'll be empowered and able to pull that data and use that data. And this is partly just cleanup. Again, earlier we talked about things like too many values, too many time series. Sometimes you got to clean things up, especially if you're generating lots of user-friendly attributes. Some things that really keep data easy to work with. JBD, again, talked about Go context, a way to thread, hey, this thing's relevant to this request through your various microservices. Picking up basically whatever attributes you tag along the way that characterize something about this data. A common set of nouns and consistent naming. I can't tell you how many folks we've worked with who have ended up with a set of logs where in some parts, in some logs generate some systems, they have app ID, some application ID, some dash ID, help future you, not pay past you. And again, like in the end, look at what you need. Look at what your developers need. Look at what makes sense for your system, right? Say you have a service where you care a lot about read performance, you care a lot about analyzing it. You're like, oh man, I really need to make sure everything is super optimized and turn all the agents there. Okay, well then, like, log as much as you can about shape read request for every single read request, so that you can go in later and slice and dice and like look at requests that have this read requests that have these characteristics. How do they perform? What about these? What about this other segment? On the other hand, let's say there's this storage engine that you're writing. You have optimized the crap out of the write path. High throughput code path, really highly optimized. Even in the case where your instrumentation library is super optimized, or super low overhead, you still probably want to be sensitive to the performance. You still probably want to be careful about how you're logging things. I don't want to log something additional for every write that you process. So that things up there. Dogmatic, let the use case dictate where you're doing. And again, this requires the folks dealing with instrumentation to understand the use case and talking across that ops developer bridge. And just because I always like to show folks what this might look like in practice, this is what Honeycomb's API schema kind of has evolved like. We started off, again, capturing these very simple, high-level HTTP parameters for each request. And then we started adding additional timers. We started adding some Kafka topic, Kafka partition, things like that. We started adding some things that were specific to the Go routines that were being run. Again, like things that were actually returned to the user in the API server. And we kind of just kept going. We kind of just kept, this is a big transition there. We kind of just kept adding more things, right? Pruning the things that weren't useful. But we wanted kind of to continue kind of building up this giant corpus of things that we could break down by, or we could measure, we could look at, because the more we were, it's just this virtuous cycle of the more we knew, the more we wanted to know, the more we could build smarter code, we could write smarter code. So, in conclusion, again, don't care what tools you use, so long as you're thinking about how you can be incorporating this sort of production data into your development process. If you're small, no compliance, whatever you do, the folks who are involved in shipping software, building software, should understand the behavior of what their software does once they throw it over the wall, or once they destroy it. Software developers should be owning observability, because we have the most to gain. Observability should be a core part of how we understand what to build and how to build it and who we're building it for. We should be coming up with lots of hypotheses about what it should be doing, validating it before we're like, cool, done, that code was definitely worth writing. We have the power to make our users happier by building better software, by making our observability tools reflect the software reality that developers live in, build IDs, feature flags, customer IDs, like things that are not just hosts and CPU and memory use. We can all be better engineers, and we can all ship better software. And by the way, all the stories that I told, they're real. You can find them at this blog URL, and that's the URL for the icons I used. Thanks.
Tak.